Hi, good to see you again. We are still in exponents. You're like, holy cow, dude. All right, so here's why we're still in exponents. Exponents have a ton of rules. I mean, you've seen that already. There's like 7 different rules and lots of different ways you can tackle them. So we wanted to spend those first couple of days just getting the basics down and some things before we started throwing a few twists in on it. So these next 2 lessons are going to talk about those twists a little bit more. So, are the properties changing? No. Okay, same properties. The only difference now is we have what we call rational exponents, which means there are fractions involved. Now, before you flip out and turn this off and say, nope, not doing it, remember, you have a calculator. Hopefully you've downloaded the app at this point. If not, library on my Google Classroom. Find it, get the app down. Might have to show you that at the end of this, just to kind of remind you. The rules are exactly the same. So I'm not going to spend a ton of time here up at the top talking about things except for what are we doing with the property. Okay? So for instance, here, when I'm looking at this, I'm like, okay, property, multiply. So here it's multiply to add. Multiply, I'm going to add the exponents. Okay? Actually, let's just do this. You're like, Hardy, why do you do this to us? Because, again, life is about kind of figuring things out, and I'm like, if we put all these different operations, that's going to be bad. So, nope. Here, we're multiplying when we go power to power. Okay? Same here, but here, remember, if there's parentheses and there's several pieces, I'm going to distribute. Still going to multiply, but I got to remember to distribute. It's just an added layer, an added piece to what we're doing. Okay? Here with negative exponents, we flip them, and as a reminder, that can be numerator to denominator, like it is here. It can be denominator to numerator. The flip, okay, taking the reciprocal is what actually is making that positive. So I got to remember to do that piece. Okay. When we're dividing, it's subtract. Remember our little personal secret rule here. We like to do big minus small to avoid those negative exponents so we're not having to add one more step to the problem. So just something to ponder a little bit. Okay. Then here again, we're still going to be doing our distribute slash multiply because we're still multiplying our exponents as we do that. And then we love the zero product property. This is great. Anything to 0 power equals 1. Anything. Fractional exponents, variables, both of them together, doesn't matter. That's still going to be 0. So even though I see all these fractions over here, which can be a little intimidating, don't get me wrong, it can be. But just remind yourself, hey, like for instance, if I'm looking at that first example, my main thing I have to look at is the exponents. Okay, well, I'm adding them. When you put the fractions in your calculator, please, oh please, oh please, okay, use parentheses for fractions. Now, if you're using your own calculator and this isn't an issue, that's great. But for us, that's critical. Because let me show you what happens if you don't. You're going to be like, oh. You're like, Hardy, it got me the same thing. Is that going to be true every time? You're not going to get that lucky every single time. There's going to be certain situations where the order of operations are going to come in. So again, even though my example kind of backfired on me on this one, there are situations that can cause a problem. So just try to remember to use the parentheses for fractions to make life easier on you. Okay, so using them. So let's come down here because we still got our examples up here we can use. So here I notice multiply is add. So I'm going to have x to the 5 halves plus 1/2. And again, a lot of you will look at that and go, well, I know what that is. 5 halves and 1 half is 6 halves. And 6 divided by 2 is 3. Cool. That's absolutely fine. If you're not sure, at least till you start seeing a few of these, that's not a big deal. I can still get it that way. But you still need to know the rule to get you to the answer, is what I'm trying to stress here. Here, same thing. Exponent, we distribute them. Oh, now I got to be careful here. 1 times 1/4 is 1/4 times, and I'm actually going to write this out just so I can see what I'm up to here. So let's see here. 5 halves times 1/4. Okay, we don't do decimals. So if you end up getting a decimal here, again, here's our math button. Math, enter, or whatever your fraction button is. We get 5/8. And for our purposes, I mean, I can check this out, 3 to the 1/4. Don't put 1.32 times x to the 5/8. If it's something that doesn't come out nice and clean, it's perfectly fine to leave it the way it is. Okay? We'll talk a little bit more in later lessons on how we can turn that into a radical form if we want to, but for now, perfectly fine. So I start looking on beyond here. Ugh, 10. Ugh. So let's see here. I'm going to zoom a little bit because that's a little bit small, or at least it seems a little bit small to me. Some of you are going to be like, it's not much bigger. A little bit bigger, though. So 12 divided by 8. Okay, let me stress. Coefficients don't play by exponent rules. Not 1.5. Math, enter. 3/2. So 3/2. Now comes the next interesting part. If we're going to use bigger minus smaller for our exponents, what if you look at the fractions and you don't know which one's bigger? 5, 6, 2/3. They both seem kind of big. I'm not sure. Here's my suggestion. Take each fraction, 5/6. 2 divided by 3. Whichever one gets you the bigger decimal is the bigger fraction. And we can do the same thing for y before we actually do the math. Okay, 2.33, a whole lot bigger than 0.4. So both of our larger exponents are in the numerator. So now when I go to subtract 5/6 minus 2/3, decimals, math editor, 1/6, up in the numerator, because that's where the larger exponent is. Same thing with my y's. Bigger, 7/3, minus smaller, 2/5. No decimals, math, enter. You're like, really? That's an actual possible answer? It is. Can't reduce this any further because, again, this isn't minus. Okay, these are coefficients, not exponents. Those bases are not the same. That's as far as I can go. So we're just kind of touching all the bases here. Oh, 0. What's anything to the 0 power again? Yeah, 1. So that whole big thing is 1. So let's see, what do we got? We got 1 over x to the 1/3 times x to the negative 5/2. And like we discussed in our many ways lesson from yesterday, now I have a choice. I can, hey, I'm multiplying these. I can add the exponents. That's perfectly legal. So if I wanted to go that route, I could be like, all right, so 1/3 plus negative, let me stress this again, this is negative, this is minus. If you're using it for negative, use this one, negative 5/2. Okay, we don't do decimals, math, enter. So x to the negative 13/6, but no negatives in your answers. So what do? I flip it up to the numerator. And if you want to put over 1, you can. Now, let's rewind for a second on this one. What if I decided, hey, what if I do my flipping right away? So I flip this up to the top. And I go at it this way. 5/2 is bigger than 1/3 because I know because that's bigger than 1 and this isn't. So if I just come to my calculator now and I do 5/2 minus 1/3, math, enter, 13/6, bigger exponents in the top, I get the same answer. Okay? So again, keep stressing. There isn't one correct way most of the time to get there. There's several. So make sure you take advantage of that opportunity. Okay, one more here and we can get you some practice. Again, you could simplify what's going on inside first, or you can distribute. Totally up to you. Maybe this time I look and I'm like, well, y3 and y1, that looks like that's pretty easy to reduce. I'm going to do that first. Okay, so 3 is bigger than 1. 3 minus 1 would be y squared. That would go on top. And I get rid of the fractional part of it. Maybe that's good to you. Maybe fractions are not your friends. I don't know. But if we go that route, we distribute through, again, no worries. We've got help if we want it. Oops, 32 will not help us though. 3/2 times 1/4, math, enter, is 3/8. So x to the 3/8. Or again, when you're multiplying, I don't know why I didn't think about telling you this before right now. When you're multiplying, you're just multiplying straight across. So for instance, here, if I'm doing 3/2 times 1/4, I don't need a common denominator or anything. I'm just multiplying straight across. So if I took that same logic for the y, and I'll show you both ways, I'd have 2/1, because any whole number can always be a fraction, times 1/4. The only thing is, make sure, can your fraction be reduced? Because if it can, it needs to be. Otherwise, it is perfectly fine to use the calculator to get there as well. Okay? Keep your examples handy. Don't just put them away like, well, I'm done with those. Put them away. Well, after you've taken a picture, of course, because you've got to upload them for slides. But otherwise, when you're getting ready for the practice, have these there. When you start doing the online stuff, hi, I'm over here. Have these out and use them to help you. But put in the practice before you're starting to do the quizzes. A lot of you keep asking me, can I reopen a quiz? Can I redo the quiz? No, you're getting, most of the time, 2 chances. Make sure you've got your stuff together and that you've practiced before you get into that. Okay? I do want to say, on the back of this sheet is where you'll find your practice. I accidentally put 2 copies of the 6-4 part 1 in here, so when you get done with this page, I didn't want to rip them out. Thought that would mess it up. You don't need to do 6-4 part 1 over again. That's kind of silly. But work through these, practice some, then check answers. Okay, take steps. And if you've got questions, reach out during one of the meets at the start of class. Reach out with an email. We'll get you set on stuff. But don't wait until the last minute. Let's get this done. Have a good day.